So in this video, we are going to talk more problems on discrete random variables, and we are going to discuss about the distribution function of the random variables. Earlier we discussed about the probability function. So what is this distribution function of random variable x? It is also known as cumulative distribution. It is also known as cumulative. It is known as cumulative distribution cumulative distribution of the random variable x of the random variable x. So what is this? The distribution function of random variable x. This is the other words for cumulative distribution function. It is represented as CDF. The distribution function the distribution function of a random variable x of a random variable capital X defined in open interval minus infinity comma infinity is given by capital F of x. See, when you did your PDF or probability function, it was always small f. That was the nomenclature. Always cumulative distribution is given by capital F. Capital F of x is the probability of x less than or equal to x. That is, it is a point S from the sample space such that your x of S is always less than or equal to x. Right. Now, what are the properties of this distribution functions? So let us go on to describe the properties of our distribution function. Properties of distribution function. Number 1. The first and foremost property reads probability of A strictly less than x less than or equal to B is nothing but your f of B minus your f of A. Second probability of A less than or equal to x, which is less than equal to B, is probability of x equal to A plus your f of B minus f of A. Your third probability of A strictly less than x less than B is equal to probability of A less than x less than equal to B minus probability of x is equal to B. Your fourth probability of A less than equal to x strictly less than B, probability of A less than x less than equal to B. Now let us consider this less than B. So A will be there, B will not be there. So this would be probability of A strictly less than x less than B, and also x equal to A has to be included. So plus probability of x equal to A. So these are certain properties which you should keep in mind while solving problems. So now we know what is a CDF. We also know the main properties of CDF. Okay, let us try to do one problem based on this CDF. We will do a problem in such a way that we summarize all the key findings which we have been doing in the previous session also. Okay, so a random variable x has the following probability function. It has the following probability function values. Okay, so let me give the table. We have x is equal to x given by our p of x corresponding values. This value runs from 0 to 7. So you will have 0, 1, 2, 3, 4, 5. We'll have a 6 and then 7. The values are corresponding probabilities are k. You will have 2k, again a 2k, a 3k, and then k squared, 2k squared, and then 7k squared plus k. Find k. Find k. Your second subdivision, evaluate probability of x less than 6, comma, probability of x greater than equal to 6, and probability of 0 less than x less than 5. Your third subdivision, find the minimum value of a, find the minimum value of a such that probability of x less than equal to a is greater than half. Probability of x less than equal to a is greater than half. Your fourth subdivision, determine the distribution of x. This is the new one. Determine the distribution of x. So we will do one at a time. Finding k already we are very familiar, so we can start right away. We know that summation pi equal to 1. So upon adding all the pi's, summation over I pi equal to 1. Therefore here we have summation I runs from 0 to 7, pi equal to 1. This implies I will have 0 plus k plus 2k plus another 2k plus 3k plus k squared plus 2k squared plus 7k squared plus k equal to 1. Now when I add all this, I will be getting a quadratic in k. So I get 10k squared plus I have 9k plus 1 equal to 0. Upon finding the roots, k will take either the value 1 by 10 or my k equal to minus 1. Now what happens? This k is directly going to reflect upon the values of the probability. We know that all pi are greater than equal to 0. Therefore, my k cannot be negative. It has to be a non-negative number. Hence, my k equal to 1 by 10. Thus, we are able to make the appropriate choice of k, which we are going to use in our table. Once we get this value, we will now get our table to be, we have our x, we have our p of x. Our x is going to run from 0 to 7. P of x also is going to run from correspondingly. So when x is 0, I'll have p of x 0. X is 1, I will have p of x is 1 by 10. X is 2, my p of x is 2 by 10. My x is 3, again it is 2k, so it is 2 by 10. When x is equal to 4, what is the value when x equal to 4? When x equal to 4, it is 3k, therefore it is 3 by 10. When x equal to 5, it is k squared, therefore it is 1 by 100. When x is equal to 6, it is 2k squared, so it is 2 by 100. And when x is 7, it is 7k squared plus k. So it is 7 by 100 plus 1 by 10, which will give me 17 by 100. So once I get this value, Now I can calculate summation over I pi and equate it to 1. This implies when I add everything, I will get 1 plus 2 is 3 plus 2, 5 plus 3, 8 by 10. 8 by 10 is the same as 80 by 100. So 81 and then 83 and then 17. When I add 100 by 101, so I have checked that all my values of the probability are correct. Now I have to find summation pi equal to 1 has been verified. So next what we have to find? Next is we need to find probability of x is strictly less than 6. We will make this a little lower so that we can do the distribution function also. I need to find probability of x less than 6. So less than 6 will be probability of x is 0 plus probability of x equal to 1 plus probability of x is 2 plus I will have probability of x is equal to 3 plus probability of x equal to 4 plus probability of x is equal to 5. So I will not include 6 in this case. So add everything. When I add everything, it is nothing but 1 minus the probability of x equal to 6 minus probability of x is equal to 7. In other words, the total probability is 1 minus this complement. So this will be 1 minus 2 by 100 minus 7 by 100. So 2 minus 9 by 100. So just look at this 17 by 100. So 2 minus 19 by 100. So this value is going to be 81 by 100. Next, I need to find probability of x greater than equal to 6. This is 1 minus probability of x which is strictly less than 6. So this is 1 minus 81 by 100. The value is again 19 by 100. So we have got both these probabilities. From 0 to 5. So we have to have 0 less than x less than 5. So 0 is not included, 5 is not included. So 1 plus 2 is 3 plus 2 is 5 plus 3 is 8 by 10. So the last probability that we have to find out is P of 0 less than x less than 5. That value is coming out to be 8 by 10. In other words, it is 4 by 5. Now moving on to the third subdivision, we have probability of x less than equal to 3. So come here, less than equal to 3 is 0, 1, 2, 3. So 0 plus 1 by 10 plus 2 by 10 plus 2 by 10. The value is going to be 5 by 10. So this value is equal to 5 by 10, which in other words is half. Now we have to go for finding a value of a. Look into this problem. Find a value of a such that x less than equal to a greater than half. Now we got half. So next we can go for probability of x less than or equal to 4. When I go for less than equal to 4, I will have 1 plus 2, 3 plus 2, 5 plus 3, 8 by 10. So this is equal to 8 by 10, which is 4 divided by 5 strictly greater than half. So my probability of x less than equal to a greater than half gives a equal to 4, because 4 is the smallest such number which satisfies our required inequality. Hence we get a equal to 4. Next, we have to find the distribution function. We have to find the distribution function. What is this distribution function? Capital F. So I have x. I will have capital F of x. My capital F of x, which is probability of x less than or equal to x. Now let us try to evaluate this value. Okay. So I will have 0. I have 1. I have 2, 3, 4, 5, 6, 7. Before filling this up, let us trace it from the previous slide. So here I want this f of x. Okay, that is nothing but my probability of x less than or equal to x. It will be easy to read from this table, so I moved upward. Now please look at this table. So if you want less than equal to, you should add the numbers which are less than that. So 0 is 0. For 1 it is 0 plus 1 by 10, 1 by 10. So what have I done? I have added these two. Similarly, here it is for 2 less than or equal to 2. I should have 0, 1 and 2. So I will add these two, 1 by 10 plus 2 by 10, which is 3 by 10. So we are adding these two. Then again, here you will have 3 plus 2, 5 by 10, 3 plus 5, 8 by 10, 8 8 by 10 is 80 by 100. So this is 81 by 100 plus 2, 83 by 100 plus 17, 100 by 100. So always we must be very cautious. Our last value should be 1. This is equal to 1. Therefore, we are correct. So this is, you are adding diagonally. I hope you are able to follow, because if it is less than equal to 5, it is less than equal to 4 plus the fifth value. So we take 8 by 10 plus 1 by 100. Like this you add diagonally and the final number that you get should be 1. This is your required distribution function. So let us fill in the values over here. We will get 0, 1 by 10, then you will have 3 by 10, then you have 5 by 10, after that you have 8 by 10, and then you have 81 by 100, after that you have 83 by 100, and then final value is 100 by 100, that is 1. So this is the distribution function of x. Okay, so this type of a problem, we have covered all the problems which we have been doing under the section of probability function as well as distribution functions. Okay, we will do one more small problem maybe, just to find out distribution functions so that you have more clarity on the topic. Right, suppose that the random variable x, suppose that the random variable x assumes assumes three values, say 0, 1, and it also takes the value 2, with the probabilities 1 by 3, 1 by 6 and half. Obtain the distribution function. Obtain the distribution function of x. So we will put a vertical table so that we have space. So we can choose x. After x, we will have p of x. After that, we will have capital F of x, which is probability of x less than or equal to x. So x takes the value 0, 1, 2. Corresponding probability 1 by 3, 1 by 6, half. So x is less than equal to 0 in the first case. So it is 1 by 3. Here it is x less than equal to 1. Therefore, it is probability of x equal to 0 plus the probability of x is equal to 1. So 1 by 3 plus 1 by 6. This will give you the value half. Next, I have probability of x less than or equal to 2. So this is nothing but I will have probability of x less than or equal to 1 plus the probability of x equal to 2. So from the previous step we have half. That half plus this half value equal to 1. So always this is your checkpoint. The final value when you find your distribution function, the last value should be 1. If you are not getting 1, it means that you have made a mistake somewhere. So you need to recheck. Okay, so now I think you will feel very comfortable with discrete random variables and problems based on discrete random variables, where you will be finding the value k, certain probabilities, probability function, distribution function, your mean, and your variance. Thank you. Thank you for your patience.